Hi, in this presentation I will be talking about Software Engineering Mentor, or SWEMentor for short. This is a code analysis and mentoring tool that I have developed as a side project. First, I will give you a little bit more motivation about why I have even decided to build this project, and I will also talk a little bit more about my development setup as well as the timeline it took me to finish this project. Then I will show you the project in a live demo, and after that I will tell you a little bit more about the project's architecture. I will also show you the tech stack that I have worked with in order to realize this project. I will also mention some future work improvement areas and end the presentation with the conclusion. So, why have I even decided to build this project? I have asked myself, what if I could build a tool that automatically reviews code and provides suggestions for improvement? This was useful to me because if I'm building some project by myself, I usually don't have the luxury of having a code reviewer. So it would be useful to have something else, or someone else, but in this case it's something else, review my code. And I wanted to build this tool, but I wanted to build it fast. So I wanted to build it in a weekend during afternoon and evening hours. I used Cursor, which is an AI-powered development environment, in order to enable faster development. And the result, which you will see, is the Software Engineering Mentor. Now let's have a look at the demo. Here you can see the user interface. So it's very basic, and it allows you to select the project upon which you want to conduct the code analysis. I will be using my project Attention is All You Need, which is also available as an open source project on my GitHub. You can find the link either on my website or in the YouTube video description. So I will go ahead and select this project, and then I will click Analyze Code. Now, this Software Engineering Mentor has started analyzing my code base, and this will take a while. Usually it takes a few minutes, somewhere between few minutes and 10 minutes, something like this. And I will unpause the recording once this is done, and then we will go back to the presentation where I will describe in more detail about how this exactly works. So, the code analysis is now finished, and let us see what Software Engineering Mentor found. So we can see, for example, that it found the issue of magic numbers. Alongside each issue, it provided the severity, the explanation, and the suggested fix. Now, if you go ahead and you actually check whether this explanation makes sense for the code base in question, and again, the code base that I have run this Software Engineering Mentor on is available on my GitHub, you will actually see that the advice here does make sense. So basically here, it's telling me that I should define all of the constants in one file instead of defining them across multiple files. Or actually to kind of avoid the magic numbers issue here. You can also see another issue, which is that I'm missing type hints. And most of my functions are missing type hints for parameters and return values. And this is also true. Again, if you have a look at my code, you will see that I have not provided type hints for most of my functions. Now, there's also some other suggestions, like short variable names and missing docstrings. If I wanted to see which issues were detected in particular for like every file and every line, I could do it here. So you can see that it also detected, and again, this was detected in one of the parts of the pipeline, that I could possibly have a security issue, but you can see that no security issue is mentioned in the final analysis. and you can also see the relevant patterns and suggestions which were retrieved for each particular issue. Now, let us go back to the presentation, and I will talk about the architecture. So, essentially, Software Engineering Mentor is a multi-agent retrieval augmented AI system, and it consists of a code analyzer agent, of a RAG agent, of the LLM service, and of the coordinator agent. So if we have a look at the high level, the system basically takes in a code base through this coordinator agent, and then the coordinator agent outputs the results. And if we have a deeper look at the coordinator agent, we will see that it coordinates the data flow between multiple different agents. So first, the coordinator agent calls the code analyzer agent. And this is the output that we have seen in the demo. And let me just go back to the demo that we have seen here under detected issues. So this is actually reported by the code analyzer agent. And what it does, it actually uses traditional methods in order to analyze the code. In particular, it uses the abstract syntax tree to detect possible issues in the code. These issues are then reported further down the pipeline to the RAG agent. So what the RAG agent does is then it takes each of these issues and it looks whether there are any suggested code issue improvements or code issue fixes, and maybe some code patterns in order to construct better quality code. And these RAG agent suggestions can be seen underneath relevant patterns and suggestions. And then finally, this detailed analysis is actually the output of the last service, which is the LLM service. So essentially, what happens is first the code analyzer agent analyzes the code base. It reports all of the issues to the RAG agent, and then the RAG agent retrieves the most relevant fixes and patterns. And then all of this, obviously filtered, is passed to the LLM service, which then actually queries the LLM, and the LLM provides the final results. In terms of the tech stack that I have used for this project, I have used for the code analyzer agent the Python's AST module. For the RAG agent, I have used ChromaDB. For the LLM, I've used Claude 3.5 Sonnet from Anthropic. And for the backend, I've used FastAPI. For the user interface, I have used HTML, CSS, Bootstrap in particular, and JavaScript. I should also note that I relied more heavily on Cursor when designing the front end because I wanted to focus on the AI and the backend parts. So, what would I suggest as some future work for this project? Well, the code analyzer agent issue detection is definitely one thing that I could improve. So as we have seen, it detected some security issues which actually weren't existent. So, the reason why is because the transformer code base mentions tokens, but they're not tokens as in security tokens, but rather tokens as in tokens in the context of natural language processing. So this is, for example, an issue that could be potentially addressed. Then another issue is the retrieval augmented agent retrieval. So basically, the thing to improve here would be the relevance of the retrieved code patterns and code issues and their solutions. One thing which could also be improved is the depth of the suggestions. So for example, it is not the same if you're recommending an improvement for a software product which should be shipped to production, and if you're recommending an improvement for a software product which is just kind of like a side project. So the recommendations for these should be different. And I think currently the software engineering mentor gives you like valid code suggestions, but it doesn't take into the account of what the software is intended to do and how many users it's intended to have, etc. Dealing with large code bases is something that should be tested. I've only tested it with like smaller code bases from my side projects, but I'm curious to see how it would deal with large code bases. And also supporting multiple languages. So currently it only supports Python, and more specifically the Python PY files, but it should also be an improvement if it would support multiple languages. So in conclusion, this tool, Software Engineering Mentor, proved to be useful. I definitely have learned a little bit about some good coding practices running it on my Attention is All You Need project. As I said, it suggested a few code improvement ideas, which do make sense. I have also done this rapidly, so just over a weekend. And basically AI-assisted development allows me to prototype very fast. But even though this was a prototype, it serves as a great starting point for future improvements, because essentially I've organized the code in a way such that if I were to continue developing this, I would have a solid base without having to refactor everything. Obviously, some polishing could probably be done, but I wouldn't have to, refactor everything from scratch. And this is it. So thank you for watching. I wanted to say that if you want to learn more about me, you can visit my website, which is listed here and also in the YouTube video description. And it contains my professional experience, publications, side projects, and more. And again, thank you for watching, and I wish you all the best through the rest of the day you're watching this video in. Bye bye.